Okay, so here's our part 2 to the cloud development video. So we were talking about how we have this parcel, this package of air. You know, again, it's not a balloon. It doesn't have sides to it. It's kind of an imaginary concept. But we have this pocket of air that's a little different than the air that's around it. For some reason, it happens to be a little bit warmer than the air nearby. And there's a number of reasons that could happen. Mountains and valleys, ponds, lakes, things like that will all play a role in this. But anyway, this little piece of air is for some reason a little bit warmer than the air that's around it. And because of that, it begins to rise. Remember, hot air is less dense than colder air. And it begins to go up, just like a hot air balloon, essentially. And as it goes up, it encounters cooler temperature. As we increase altitude, the parcel of air is going to encounter cooling or cooler air temperatures. And this is what we mean by environmental cooling. At the same time, though, it's also cooling adiabatically. And this means that as it's expanding due to a lack in air pressure or a decrease in air pressure, it's expanding. And because it's expanding, its temperature is dropping. Now, here's the key to forming a cloud. Eventually, it's going to cool enough to the point where it reaches the dew point temperature. When this has happened, our water vapor in the cloud condenses, or our water vapor in the air parcel, rather, condenses, and we have a cloud forming. The dew point temperature in this diagram is right here. I'll put dP. Once the air got above this line, it cooled to the point where the water vapor was converted into condensation. It crossed above the dew point temperature, or crossed below into the dew point temperature, I guess, and then condensed. If it were cold enough, it would form ice crystals. So at this point now, we have condensation, maybe even ice crystals if it's cold enough. So that's the basic idea. It cools in two ways. It cools from the environment as it's rising in altitude. It cools due to an expansion of the gas, just like those CO2 cars in tech. Those get cold when the gas expands. So we have an expansion of gas. It's cooling. And eventually it reaches the dew point temperature. Now you might have noticed clouds usually, or often anyway, have flat bottoms. And this is why. Below the line, we're going to have evaporation. Above the dew point temperature, we're going to have condensation. And the dew point temperature is usually represented by a flat horizontal line because, again, as you go higher in altitude, we have a decrease in temperature. So the decrease in temperature is going to be consistent anywhere along the line. So this is why most clouds tend to have flat bottoms and then kind of like puffy tops. You know, that's usually what we see. So let's go ahead and just fill in the notes here. So cooling air, cooling the atmosphere, we have adiabatic cooling. As air rises, the pressure surrounding the parcel of air decreases, and because of this, the parcel of air expands. As it expands, it becomes cooler. This is just like the CO2 cars in tech. And there are lots of other examples of this, but I think that's probably the easiest one to understand. Eventually, the parcel is going to cool to its dew point temperature. That causes the water vapor in the air to condense, and we have a cloud appear in the sky. So that's the basic process to how clouds form, slightly complex. Now I think tomorrow, or on Tuesday rather, we'll take a look at types of clouds. There's lots of different types of clouds, as you know. Some of them are the white puffy clouds, and then we have storm clouds, and we'll look at different types of clouds on Tuesday. But I think that's good for today. So anyway, I hope these videos make sense to you. You know, if things are confusing, watch them again until things start to make more sense. This is also a kind of complex idea. But remember, two parts to the cooling. It cools due to a rise in altitude, and also the cooling adiabatically due to an expansion of a gas. that causes cooling. We reach the dew point temperature, cross over into condensation, we get clouds forming. Okay, so anyway, that's it for part 2 of cloud development. Okay, good luck.